Let's do a quick example. Let's say that we have two square pieces of material. Okay. And these two square pieces of material are going to each be a length of 7.5 centimeters per side. So, and I want to make a capacitor out of this. And so it's not going to be much capacitance because if you put them close together, they'll short out, and that's not very big. But if instead I take my metal plate and I put a very thin dielectric in between, that will act like an insulator. And so I'm going to assume that I'm able to use a dielectric that is only 0.0541 millimeters thick. Okay, and I'm going to use paper as a dielectric. So I get a very, very thin piece of paper. And so I look up in the book and I find the dielectric constant of paper is 3.5. And so I want to know, what is this capacitance right here? Okay. So the capacitance, we know, is kappa epsilon naught A over D. Well, it's square, so the area is going to be the length of each side squared over D. So the capacitance is going to be equal to 3.5 times 8.85 times 10 to the minus 12 farads per meter times the length, so 0.075 meters squared, divided by the separation, which was the 0.0541 millimeters is 5.41 times 10 to the minus 5th meters. So the capacitance comes out to be 3.22 times 10 to the minus 8 farads, or that would often be written as 0.0322 microfarads. Okay, so there's the capacitance right there. And so the next question is, what's the maximum voltage I can put on the capacitor before it breaks down? Well, the maximum voltage is the dielectric strength. So you look up in the table and it says it's 16 kilovolts per millimeter. Well, that actually turns out to be very useful because we know that the voltage is E times D. And so if I just use those units that are right there, kilovolts per millimeter, and then multiply by the thickness of this thing, which was 0.0541 millimeters, then what I come up with is 0.866 kilovolts, or in other words, 866 volts. So I could put 866 volts on that thing. Now, that means if we could somehow get even thinner pieces of paper, then we could get even higher voltages, rather, we could get higher capacitances. Now, the thinner the paper, the less the voltage you can handle. So as long as we're not getting too radical here, okay, then we could actually make an extremely big capacitor with just using paper as my dielectric. So the other thing is that we got these square plates. Well, there's nothing that stops us once we put put this thing together, rolling it up to put it into a little small tube. Okay, and so that would be manufacturing-wise a very efficient way of doing this, making a very big capacitor in a very small circuit element, a little small package. And so that's really how we do this. So that's another advantage of using dielectrics.